All right, here we are with our Calc 3 notes again. This is page, oh crud, I forgot, 11? Where are we? Page 11. And we're talking in section 12.3 about the dot product, which is a multiplication of two vectors which results in a scalar. And these are the properties of the dot product. Okay, so if u, v, and w are any vectors, c is any scalar, then if I take the dot product of u with v, so u dot v, that's equal to the dot product of v with u. Again, I'm not going to prove all of these to you. Make sure you read through them and understand. They're pretty easy to understand though, because if I do u dot v, we know that's u1 v1 plus u2 v2 plus u3 v3. And if I do v dot u, that would be v1 u1 plus v2 u. So it doesn't matter. Like if I multiply 2 times 3, it's the same as 3 times 2, right? So that order there doesn't matter. If I take the dot product of u with the addition of v plus w, I can just distribute through, just like if I were distributing a scalar through. If I have 0 dotted with u, it's certainly going to give me the 0 vector, etc. Okay. Also, one thing that's very important is notice that the length of u squared is actually u dot u, which makes sense, right? u1 times u1 is u1 squared, plus u2 times u2, u2 squared. So it's the same way of writing the length of u squared, and sometimes we'll see that when when that's what we want, either one of those. Okay. All right, so some more definitions. These are two very important things that we'll use throughout the course. One is called the vector projection of u onto the vector v. Okay, that's a vector actually. So by notation, we write it this way. So PROJ means the projection of u onto the vector v. So v is a subscript written right after PROJ. So projection of u onto vector v. It's defined as the dot product of u with v, u dot v, divided by the length of v squared, so this is going to be a scalar, times the vector v. Okay, now the scalar component of u in the direction of v is a scalar, so that scalar is the length of u times the cosine of theta, which is u dot v over length of v. So that's actually this piece of it, right? U dot v over length of v, and if I brought one of the length of v's over here, that would be the unit vector in the direction of v, right? So it's just the way to think about it. So in other words, what does that mean? So here's a picture of what's going on. If I have any vector v, and I have another vector u, and again, we're always assuming that their initial points are at the origin, so when I draw pictures like that, remember that. So if I want to do the projection of v onto u, what I mean by the projection is it's called the orthogonal projection sometimes, because you drop straight down, so there's a 90-degree angle between dropping this tip straight down, and then the vector that's formed that's in the same direction of v is the projection of u onto v. So geometrically, we're just dropping the tip of u straight down onto v. Okay. Now, what's the length of that? The length of that is u cosine v. I mean u cosine theta. The length of u times the cosine of theta. Okay. So why is that true? That's true because the cosine of theta, right? If you just think about this as a right triangle, right? Cosine of theta is adjacent over hypotenuse. So the adjacent is the length of this projection vector divided by the length of u. So the projection vector divided by the length of u gives me the cosine of theta. Okay, so you can see that by manipulating these guys algebraically. But that's the important part to remember, what this vector is and what its formula is for computing it. So for example, if I have two vectors, u and v, and I want I want the vector projection of u onto v first, and then I want the scalar component of u in the direction of v. So what does that mean? Here's the projection of v onto u. Okay, so that means it's u dot v divided by the length of v squared times v. Okay, projection. Ooh, I wrote that backwards. Ah, sorry. Guys, this is the projection of u onto v. Please correct that in your notes. Projection of u, where this v is, should be a u, onto v. Okay, I'll correct that in the notes I post next time, but just remember this should be u onto v. So it's u dot v divided by length of v squared times v, right? And it makes sense. I'm projecting u onto v. It should be some scalar component times the vector v. So these are just mechanical now, right? Take the dot product, take the length of v squared, multiply it times the vector v. This is just a scalar when I simplify it into minus 4/9. Here's v, multiply minus 4/9 times each component, and there's your resultant vector, which is the projection of u onto v. Remember, these should be switched. And the scalar component of u in the direction of v is the length of u times the cosine of theta. So that's u dot v over length of v. Again, easy, just mechanical at this point once you know how to do these things, and you get minus 4/3.